I am Kenneth Kinderwater, and I'm proud to present Circuitry, your mobile, renewable, and adaptable energy source. Nature inspires us in many ways. We can be biomimicry, where we copy what we'd like to see in nature and use what we need, or we can transmute and bioengineer nature to get what we want out of what they like. In 2000, the Sydney Olympic Speedos was introduced. In 2000 Sydney Olympics, Speedo introduced their fast skin swimsuit designed to biomimic a shark skin's denticles, which kind of capture water and allow streamlined movement through the water. Numerous world records were set with this swimsuit. The Olympic Committee deemed that this technology was advantage and has been banned in competition. I think they might have brought it back recently, but it was kind of a major shift in biomimicry. Japanese high-speed trains. They were moving at such a speed they had a tunnel boom. Air molecules were contrasting and expanding, causing loud noises when exiting and entering tunnels. Engineers observed kingfishers, bone structures, and borrowed their structure to provide a nose cone for the train, reducing noise and improving performance. Nature engineering. GMO foods. Oh, sorry. Can you guys hear me now? GMO food, potatoes, cauliflower, wheat. They've all been engineered over generations to provide sustainable fuel for our human needs and now are a staple of many diets. In Northwest India, the Kazi people have been growing and molding rubber fig trees to act as bridges over rivers and canyons. And you got to ask yourself, why haven't we bioengineered nature's most sustainable and tenured solar-powered producers? I understand this is a lofty goal. So my device that I invented is a lofty goal that takes time, knowledge, and funding to reach this goal. Circuitry is an invention that is a step in the right direction to produce a sustainable source of revenue to fund research and development for this distant goal. If you can control the flow of funding, you can control the goal. Here's a little quick demo of my
Circuitry, your mobile, renewable energy source that meets your needs on the go. Always looking for a place where you can charge your phone? Circuitry can do that. Are your plants wilting, not getting enough sunlight? Mine aren't, because I use Circuitry's powerful light sensor to help find the best light for my plant. Wow, what a shot! Circuitry keeps me powered up and connected while on the course. Out camping and the sun is setting fast? Circuitry can help light the way. Quick, set your tent up before the bears attack. You can set the mood for your next backyard rave. You aren't limited by pesky outlets. String up LEDs anytime, anywhere. Utilize the online dashboard to check the current battery percentage. Accurate and up-to-date weather information sourced from openweathermaps.com. Circuitry's light sensor can tell you the intensity of the rays that are hitting your system. Keep connected with your home Wi-Fi network or mobile hotspot. Circuitry can follow you anywhere you want to go. Circuitry can do it all. It can even help with your putting. Kind of.
Time to take in that beautiful sunset at the crest. Oh, all right. So Circuitry publishes local GPS data on the sensor located in the device. The GPS gathers the longitude and latitude data. We push these coordinates to the Open Weather API to get up-to-date weather information. Data is not gathered locally. It is a national database, so I have noticed that wind speed can be a little bit off, but I'm not disappointed with the results. I use the Adafruit spectral sensor to gather the wavelengths that are affecting the solar panels. The output of the wavelength measures the intensity of the wavelengths through the whole visible spectrum. Plants mostly use blue and red light to gather or to grow, stimulating stem growth, leaf growth. Solar panels use mostly the full visible spectrum to power to generate power. So I mostly focused on the red and blue wavelengths, as you can see in this slide. There's something interesting. The haze recently, we've seen a lot of haze and smoke in the city. So I noticed that the blue wavelengths have been blocked a lot by that. This is this line right here shows the full visible spectrum. In the morning, you can see kind of the sun rise over the sandias and hit the solar sensor that I have in the little flower on the top. So it's pretty cool to see the different visible light spectrums hitting the solar cells. Here we go. Here is my fritzing or layout of the sensors. We have electrons coming from the solar cells here, going through the Adafruit charge controller. The charge controller then powers in a battery located on the top right. I use a 5,000 milliwatt hour battery to run my system, which outputs about 3.7 volts to 4.2 volts. On a perfect day, the solar cells can export 2 amps, and it should take about 2.5 hours to charge the battery to full 100%. The load passes through our fuel gauge here, which provides the battery percentage that I have exported on the dashboard that you can see. Then the battery then controls and powers the Photon 2. Our Photon 2 is used to gather information and power our GPS sensor and our solar sensor. The Photon 2 also provides energy to our power booster. The power booster can take voltages from 3 volts and up to voltage to a continuous 5 volts. From that 5 volts, we can charge our phones, we can charge LED strips, and basically it has a USB port here located at the end. Anything you can plug in a USB port, we can use to use the energies. Here is my code. I had to kind of publish a lot of data. A lot of this data was the light sensor or the intensity of the spectrum from each of the lights and the data, weather, GPS location. The Adafruit dashboard, the feeds that I feed for publication, I was limited to 10, so I had to really choose what information I want to provide. I decided to leave out orange and green on the spectrum just because plants don't really use that, and it's incorporated in the full spectrum. Let's see. I decided to go with a lot of functions when gathering and implementing my data. My functions are located down here. We have light sensor read, battery gauge read. Basically, all the information that you see on the dashboard, I can push through my functions. For testing purposes, I decided to gather data and publish to my dashboards every 30 seconds, but that can be configured to every 6 hours or whenever the light intensity is above a certain threshold. Here's the background workings of my dashboard. One negative drawback from Node-RED is that it needs to be running in the background of your machine, so it kind of can't gather data while working remote or out and about while camping or golfing or doing your local outdoor hobbies. Publishing the Latin long location for the weather API and then projecting that onto the map was very fun. I had a good time configuring that, and I was really proud and really ecstatic to see the output where it shows your location and the current weather conditions. The capabilities of my circuitry, I really wanted to be able to charge a phone and a strip of LEDs. Phones require 5 volts and a minimum of 1 amp. LEDs are also 5 volts. And I wanted to use the GPS location for future use. To go above and beyond, I really wanted to have an API, weather API tie-in. I'd like to be able to up the voltage to 12 volts, but that was kind of limited by the resource that we had available here. I really wanted to be able to daisy chain my 2 circuitries or multiple circuitries together to increase power and increase power. I would really kind of wanted a night light, so if you're walking around at night, you can just have like a little footpath guide for the night light, but limited in time and resources. Project management. This was a very big crunch going on. My strategy was to break in the objectives or my actions into light groupings. I had my planning phase, which was kind of a lot of thinking about what kind of issues were going on, how I could kind of bring my idea to life. I appreciate Dr. Brian and EJ kind of giving me guidance on moving forward. Design sourcing materials, I was limited to kind of what would come really quickly. So my solar cell form factors were pretty small. SolidWorks, that took kind of 2 generations of SolidWorks printing for leaves. My first generation or my first vision, my leaf was kind of too big and it's kind of not very practical. So I had to go back and remake my generation 2 leaf, which you saw was kind of smaller. Assembly was tough. I had to kind of fit everything together in a nice, clean way. Coding, we had a lot of practice coding, so that was not the most difficult part. I would say one of the most difficult parts of the presentation was actually giving out the presentation in my video skills. Hopefully that's going pretty good. Some lessons learned. Oh man. When they coined the phrase "a spark of excitement," I think they were working with batteries. Connections weren't as strong as they needed to be, so it kind of allowed the path of least resistance to kind of loop back and cause some discharge of sparks and stuff like that, but we were able to handle that moving forward. Moving forward, I would probably have ensured more fit connections. A lot of the sensors came undone in transit, so I really want to make sure that that is not an issue moving forward. 3D printing is a godsend. We can make anything that we want to, but sometimes your measurements or your future images does not incorporate everything that needs to go into it. So I would build larger access ports. I had to do some late night engineering and kind of enlarge some access ports to help fit everything in, especially the cabling and wiring. Future builds, circuitry generation 2, I would say I would like to improve the photovoltaics. I was really limited to kind of what Amazon had, so it wasn't the best and most efficient steel solar cells. I would again ensure connections are a little stronger, improve the battery pack. I was limited by power output for that battery, but I was really surprised in what we were able to do with 5 volts. And also transportation mode. I kind of talk about how moving it around, but it was very fragile with the 3D printing and kind of the inset it have all built together. Circuitry Generation X, the main goal again is to engineer plants to be able to create solar energy for us to use. So I would like to work with the photosynthesis process, maybe transmute the chemical process that they have. And then like the bridges that they had built in, I would like to kind of maybe mold and grow trees and plants to kind of act as a conduit for energy if we even just hold our photovoltaics. Here's my contact information. Before I go to the final slide, I'd like to thank EJ, Dr. Rashab, Jamie, for all the help. You guys are a great source of knowledge, and I appreciate your guidance and learning all the different sensors that we had to go through.